let me introduce myself. I'm Mark Brownstein. I'm General Counsel of the Energy Program at Environmental Defense Fund. And I will be the moderator of this, what will be this discussion this morning on the relationship between transmission and distribution and the role of the smart grid in the operation of those two very important pieces of the energy puzzle. And we thought today, rather than structure this as a series of PowerPoints and show and tell presentations, that we would basically pick up on the format that you just participated in, where we would have more of a discussion amongst our very qualified and esteemed panelists, and hopefully also get you guys involved in that discussion on the topic of transmission, distribution, and its relationship to the smart grid, and how the smart grid in turn can help both of those systems operate more efficiently. And I'll start simply by saying that in my experience, having spent 10 years in the electric utility business before coming to Environmental Defense Fund 6 years ago, that I can tell you that there were always at least 3 tribes inside of our utility. There was the generation tribe, there was the distribution tribe, and there was the transmission tribe. And while we all worked for the same company, and this was the days before deregulation and disaggregation, and were managed by the same management structure, it's fair to say that each tribe had its own set of ideas about what was important, and of course they all each thought they were the most important member of the community in our utility. And very often they operated separately from each other. I mean, those sort of tribal differences emerged because basically they had the luxury of just simply thinking about their individual piece of the larger puzzle. And I would say that some of that has permeated not only how utilities continue to think about transmission and distribution, but arguably it continues to permeate how we as policymakers, we as regulators, we as academics continue to think about the system. And so what we wanted to do this morning is really use this panel to begin to break down those sort of tribal barriers a little bit and start to really talk about the relationship between transmission and distribution. What is the relationship between those two important parts of the system? And in turn, how does the development of smart grid technologies make a difference in how those systems operate, and what new challenges does it present for each? And I am joined this morning by a set of really excellent panelists. Get my thing out here. Get everyone's name correctly. Thank you. Sitting immediately to my left is Philip Moeller, Commissioner of the Federal Energy Regulatory Commission, and someone who himself has had a background in the generation business. Was it, Phil? Right. Been generation and utility business before coming on to the FERC, so has a lot of practical knowledge to go along with the wisdom that comes with being a member of the commission. Then sitting next to Phil is Chantal Hendrzak. Is close enough? She's Director of Applied Solutions at PJM. For those of you who are not familiar, PJM is the RTO, the Regional Transmission Organization, that really manages a large swath of the electric grid, stretching from New Jersey all the way out here to Illinois, and I think it still holds the position as the world's largest competitive power market. Is that right? Sitting next to Chantal is Paul Centolella, who's Commissioner of the Public Utilities Commission for the state of Ohio. Paul himself, before coming to the Utility Commission, also has a rich history working in the industry as a consumer advocate, among other things. Paul and I have spent many an evening over a beer talking about the state of the world, and I think you'll enjoy the conversation this morning as much as I have done over those beers. And then lastly, Vladimir, and Vladimir, let me not butcher your last name. Koritarov.
Yes.
Did I get that right? Okay.
That's right.
Vladimir is Deputy Director of the Center for Energy, Environment, and Economic Systems Analysis at Argonne National Laboratory. So he's our local boy this morning, and has 30 years plus experience working with the electric system. He is a leading expert in the modeling of such systems, knows a tremendous amount about the technical underpinnings of the system, and so we're pleased to have him here rounding out the panel. And so the way this will go is we'll spend a little bit of time, I'll be peppering these experts with some questions, and then we want to open it up to you all to participate in the conversation as well. But let me start off, Vladimir, with you. Could you just, in very simple terms, let's make sure that we all understand what we're talking about here. When we talk about the transmission system, and we talk about the distribution system, what are those things? And what differentiates them?
Well, both are the part of a bigger picture. That's the power system in general. And most of you are familiar with the power systems, but for those that are not really that familiar, let me just try to put a very brief explanation about how does it work. I mean, we have a generation of electricity on one side, so typically we have generation plants with generating units producing electricity. That power is stepped up with step-up transformers to transmission voltage level, and then it is fed into the transmission system, which is a high voltage network of transmission lines. And then through this transmission network, the power is basically distributed to the consumer centers. And once it is close to the consumer centers, then it goes down through substations to the distribution network to the low voltage, and then it is distributed through mostly radial network to the consumers who supplies the power there. So the big difference between the transmission and distribution networks are that, for one, transmission networks are typically high voltage, typically 110, 230, 345, 500, 750 kV, while the distribution network is low voltage, typically 69 and below kV. The other main difference is that with transmission networks, we can have a meshed network with the power flows going from point A to point B in different ways. So we can have even loop flows in the transmission network. Distribution networks are typically radial, meaning that the power flow goes from higher voltage to the lower voltage, typically in just one direction, and from the transmission network or from the substations toward the consumers. So that's how it has been for the last 100 years or so. Now with the smart grid, we are trying to do something different. First, in the transmission network, we are trying to be more able to control the power flow, because in the transmission network, typically we have very limited capabilities of controlling how the power will flow. The electricity usually flows taking the path of least resistance, and sometimes we can do some actions to change the impedance on transmission lines so that we can direct some of the power through certain lines. We can use also some devices like FACTS that can help us with doing that, but typically our capabilities in that are very limited. On the other hand, with distribution networks, the power was always flowing in one direction only so far, but now with the new technologies that are coming up, there is also a need to accommodate two-way power flows. So smart grid will be also trying to help us with that part. And that's one of the issues that we'll be, I guess, discussing more during this session and throughout this conference.
So thank you for that. Oftentimes I hear people describe it as in a very simple way, the difference being, the difference between the interstate highway system, the freeways, which is the large transmission systems that get you from state to state very quickly, and then the local roads, right? You hit
That's
the
right.
exit ramp, and then you're driving on the city streets, and even the country back roads, and that is what we often think of as the distribution system.
Yes, that's exactly right.
So thank you for that. And Chantal, maybe you can talk a little bit about who runs this system. I mean, does it just run itself?
I wouldn't have a job if it did. Yeah, so there are these different systems. There are 13. There are 3 different interconnections in the U.S. There's the Eastern interconnection that pretty much goes from the coast to the mountain range, and then you've got the Western interconnections from the mountain range out to the West Coast, and then you have the state of Texas. For the most part, they really are not interconnected. There may be a few ties that go in between the grids, but they really do operate as 3 different interconnections. So you think of all of a particular interconnection as all the machines essentially spinning 60 hertz, pretty much to the same. Yet when you have disturbances and things like that, because we're all interconnected, and we heard a little bit this morning about wide area situational awareness or wide area measurement systems, it's because we all are in each interconnection connected, electrically connected in some way. There are a couple of different ways, organizationally speaking, that the grid is monitored. PJM is a regional transmission organization that monitors a piece of the Eastern interconnection. So we have 15 different states, DC area, so New Jersey down to some parts of Kentucky out to Illinois. And we're bordered by the New York ISO, who has the state of New York to our north, the Midwest ISO, which has the states to the west of us, and then down south and southern. A lot of coordination even with those that were not immediately near us, like the ISO New England, and then up in Canada as well, because we're also electrically connected there. The role of an entity like PJM is to look at the interstate highway aspect. Our members, we have over 600 members, our members are the folks who are looking at sort of those back country roads, the distribution companies, the generation owners, and then some pure financial players. So the role of a group like PJM, essentially threefold. We monitor the grid. We worry about the operations of it. We make sure we don't own any assets, but we are forecasting what the load is going to be, making sure that the generation is available to meet that load, both in a sort of a day ahead type of scenario, in a real-time scenario, in a second-by-second scenario. We have things like ancillary services, which come along with the wholesale energy markets that we run, that help with the fact that everyone's switching off and on their lights and dishwashers and things like that. You get those slight fluctuations in power, and because we don't have a grand proliferation of energy storage right now, you pretty much need the power to be there when it isn't, to be there when you need it and go away when it isn't needed. So we run different wholesale energy markets, some of those ancillary services type of markets to help like regulation control, to make sure that we can try to keep it around 60 hertz as much as possible by paying generators, for example, to be there spinning and be able to reg up or reg down based on what the need is of the grid. So we run the grid from an operations perspective, make sure that power is there when it's needed and then it has a place to go when it's not needed from a wide area view. We run wholesale energy markets, so a synonym is sort of, you think of the New York Stock Exchange, where people are scheduling their power to move from point A to point B, which could be within PJM or into or out of or through PJM. And then we have these ancillary services to supplement the real-time operations. And then we also have a forward-looking role, which is in the planning area, where we're looking out about 15 years into the future about what the load is forecasted to be, about what generation is expected to be built through the generation interconnection process that we have. And we look at what the grid, how the grid is going to be changing based on where the load is expected to go and the generation expected to be built, and forecast what modifications need to be made on the grid. Do we need new lines built, for example? Do some lines need to be modified or upgraded or things like that? We look at the retirements, the generation retirements, and how that's going to impact the grid. And then we work with our members to come up with some solutions to some of the different problems that we see on the grid, and then work through to get the work done.
So as I understand it, you're one part system operator, right? You're looking at the system to make sure on a moment-by-moment basis it's running and it's reliable and the lights are on. You're one part system planner, so you're anticipating how uses of the system will change over time. And then you're one part market maker or market operator. You're running a financial market, essentially, for all these products: energy, capacity, ancillary services. We'll probably talk a little bit more about what these things are, but these basic products, right, that are sold to the system, right? And that, in turn, keeps the system running. So that's a lot of hats to wear. So now let me ask this question. Okay, so I want to build a transmission line. Okay, I'm looking at the system and I'm noticing that it's very difficult, it seems, to get power from, say, Minnesota to Chicago. Okay, and I want to build a transmission line in order to be able to move that power. Let's say, for example, I want to build a wind farm somewhere in western Minnesota because it's very windy, and I want to bring my power into the Chicago market, where I know that prices are very attractive for delivering my power. Who do I have to go to get permission to do that?
I'll give that a try. I'm Phil Moeller with the Federal Energy Regulatory Commission, and we really don't have much authority over that decision. We, in this country, have different sets of policies as to who decides where energy pipes and wires go. If you want to build an interstate natural gas pipeline, you would come to FERC and we would give you a certificate of public convenience and necessity once you proved that it was safe and the economics justified it. But in the case of something equivalent on the electricity side, we have very limited authority to be the siting agency. And so it falls to, on the siting side, either states or localities. Some states have a one-stop shopping for siting. Other states, you have to go county by county. And that's just the siting side of it. The, at times, more difficult decision is who pays for it. And there is one model that an entity under the merchant model would pay for it themselves, but these are such huge investments that's very difficult to usually pull off unless it's a very distinct project. And usually what has to happen is that if the entity proposing to build the line, or it could be in often cases a consortium of entities want to build a line, they will go to both my colleague at the state level, in this case, Commissioner Centolella in Ohio. Of course, he wouldn't be approving something from Minnesota to Chicago, but if something goes through Ohio, he would have a role. But so would Chantal and her agency, as they determine, first of all, if it's needed in a projection, and then who should in some way pay for it under some type of methodology that we will probably bless at the FERC if it has had proper stakeholder support in the region. Then it gets a little more complicated if in the case of Minnesota to Chicago, you're talking about crossing markets. So you'd be going from the Midwest market to the PJM market, and that gets even more complicated as to who pays for it, because everybody wants to benefit, but usually if you can get away with paying less, you probably want to. And that's one of the things we've tried to address in our recent Order 1000 at FERC, which is a wide-ranging order, but one of the things that could be possibly the most helpful part of it is directing the regions to come up with kind of common planning assumptions, and we've given them roughly 18 months to come back to us with a process where these kind of inter-regional lines, big lines that can move a lot of power, usually green power going forward, can have a more predictable way to be considered.
So I'll go to Chantal to figure out whether my line is quote-unquote needed, right? I'll go to Commissioner Centolella to find out if I can actually cite my line. And I'll go to you to tell me how much I can charge?
Correct.
Okay, this is, wow.
And Mark, don't forget that if you pass through a national forest, you're probably going to have to go to a different federal agency to get.
Wow.
Land
So,
use approval.
so, okay. Now, but the good news is if I come to you, right, there are provisions in the law that allows you to give me sort of bonus recovery, right, for building this because this is a big headache. So you will give me a certain return on investment that is reflects the challenge of doing this, correct?
Correct. We, under federal law, we've been directed to consider transmission incentives for these projects, partly because it is so hard to cite them, partly because it's hard to figure out who pays for which portion of the lines, because you're talking about an asset that's going to be used for 40 or 50 years, and yet you're kind of setting a snapshot as to current usage as to who should pay for it. But if you think about the road analogy, we build roads through the gas tax that we pay, but if we move away, we're paying for a road here that we're not using. So it's a very inexact science to try and exactly figure out who should pay how much for a major transmission line. That's part of what makes it difficult. That's part of what adds to the risk.
So, okay, so I get that. It could actually be worth my while to build this transmission line. Now, let me change it around a little bit. Maybe I don't want to do that. Maybe instead, rather than bring the renewable energy in all the way from Minnesota, right, I want to site renewable energy facilities right here in the Chicagoland area, right? As I was driving in today, I noticed there were some wind turbines on top of the office buildings and some solar panels, and maybe that's the solution. Do I go to you, Commissioner, or do I go to you, Commissioner? Now what do I do?
Well, you're probably coming more to the State Commission than you are to FERC because you're not building a transmission line here, and FERC's jurisdiction is over wholesale power transactions and transmission in interstate commerce. So if there is a siting jurisdiction actually in our state, it wouldn't technically come to me. It would come to a separate board called the Ohio Power Siting Board,
Okay.
which includes the chairman of our commission and the director of the environmental agency and the director of the natural resource agency. And, and so all of the people who have to provide permits in Ohio sit on that board. And, and if you're citing a major facility, you would cite there. But if you're putting, your solar panels on top of, a Walmart or an office tower, you probably aren't a major facility and you don't need that siting authority. Now, you will need to follow the interconnection standards, which are established by our orders that the utilities have, and you'll want to have some discussion about whether or not you're selling that power back into the grid or whether you're using it in your own facility.
Ah, okay, so now that's very interesting, because I know if I go to Commissioner Moeller with my transmission line, he's going to give me a fixed rate of return, a return on equity. Is that right? And, the cases have been all over the place. You just approved one yesterday for about 11 and some odd %. right? Fixed ROE, right? So I can,
Fixed part was lower, but I probably shouldn't talk about it because it's
Yeah.
still
but I can, so I can get it, now, but if I build my solar panel on the roofs of Chicago, how much money am I going to make there?
Well, if you want to sell back into the market, and since you're talking about making money, I assume that's what you want to do.
Yeah.
And it's going to depend upon what the market price is, either the locational market price, at the point on the grid where you're selling and the times when you're selling it, because recognize PJM is calculating, several thousand individual market prices every 5 minutes in order to capture how they dispatch generation and operate the transmission grid, because that's the only way they can operate it effectively. And you're also probably going to have a stream of what are called renewable energy credits, which you can sell in a separate market and get a value for that, either through a long-term contract or through some sort of year-by-year agreement with a utility or someone else who wants those renewable energy credits.
So that may or may not be more or less than what I could earn building that transmission line.
It's all going to depend upon the economics of where you are at that particular time.
Got it.
I mean, and this is one of the things that makes transmission siting so difficult, is because transmission siting is based on a particular forecast done at a particular point in time, and whether or not you in that forecast, have a need given the reliability standard. And of course, next year, PJM will do another forecast and the result might be different, which makes siting that transmission, if we're going on those kinds of black and white standards, very difficult.
So now let me turn to Vladimir for a second. So now, okay, so we've got these two competing, this is what I'm trying to figure out here. I could build my transmission line and bring in electricity from far away, from wind farm, could be a nuclear plant, hydro plant, but I'm going to bring it in, and my transmission line is going to be what's going to deliver it here to Chicago. Or I could, for argument's sake, build solar and wind right here in Chicago. From an electrical engineering standpoint, is it 6 of one, half dozen of the other? Does it matter which one I do if you're thinking about the integrity of the system? Do you have a thought on that?
Well, from the integrity of the system, it does matter somewhat. I mean, you have reliability of the system, which is basically maintained by the system operator, and the system operator controls the system operation with all aspects of its operation. So now the question is, the difference between the centralized generation and distributed generation. Well, there is a debate going on about that. There is a lot of papers coming out, and many authors are thinking that naturally distributed generation should be more reliable because it's spread out through the entire area, and it's less likely to be out all at the same time and so on. So that is one of the pluses. On the other hand, there is also the cost, and economics are always a big part of reliability, because reliability and economics, that's the equation there. And distributed generation so far is still more expensive than the centralized one. So even if you have a good location for some distributed source and so on, you can go ahead and you can produce that energy and you can sell it in the market. I mean, we have the net metering in many places around the US now, so that it allows you to generate your own electricity and sell surplus back to the market. And that's maybe a good business model in certain locations. But in many locations, that is still a little bit less economical because, the technology to produce electricity is still dependent on the laws of, size, and the size matters in that case. So that, if you're producing with a large wind farm, which is more efficient, and you have a connection to the grid that is close by, you may be better off. So we have so far more of the large renewable resource development in the recent years than the distributed resource development. Most of the 40,000 megawatts of wind that is now operating the system is in the large wind farms, not so much on the individual windmills that are in the backyard or on the rooftop and so on. That case, may change in the next few years or in the next 10 or 15 years, depending on the economics. But also the solar is going to be a very important issue. And the solar, with the advance of new panels, new technologies, and higher efficiency of individual panels, that may be something that is going to be basically progressing on both fronts simultaneously, so that we have also big solar farms coming to the system. And we already have about 1,400 megawatts of solar PV capacity in the US. But there could be also a lot of rooftop solar, which will enable people to put some solar panels on their roof and complement their electricity from the grid with their own electricity production from the rooftop solar panels. And with the development of the electronics, of the control systems, of the home energy management systems, that is something that looks like a pretty good proposition. So in the next 5 to 10 years, I would expect that there will be a lot of those things happening.
So Chantal, do you, from the perspective of PJM, do you care which I do, whether I build the transmission line into Chicago or deploy a lot of distributed generation in the city? Does that matter from a PJM operations perspective or from a market perspective?
Well, certainly in the former, where you're building the transmission line across the system, we would get into doing the studies that Phil was talking about and looking at, is there a need, is there either a reliability or an economic need, would there need to be a new line built, would there need to be upgrades to existing, so there would be responsibilities we would have associated with that. For the more distributed generation scenario, that happens more locally. Now, we do get more involved if you are going to be selling back to the grid. Then we need to look at the interconnection points and what the responsibilities are there and what the impact is going to be of that. If you're building something where you're going to be consuming all the energy yourself and there's likely not going to be a surplus, then we wouldn't get involved because you're not injecting into the grid.
So if I own a bunch of supermarkets in the greater Chicago area and I put them on my roof, but I don't sell the power back to you, but rather just consume it locally, then you don't really care.
Right, it's not as much of an impact to the grid because you're not going to be injecting power onto the grid. It's more happening sort of behind the meter or locally at your location.
But it would have, okay, and just to play that out, so if you were selling that power back to the grid, then of course you right, that would involve you.
Right. Then
Okay.
PJM would get more involved.
Well, that's interesting. So, but even if I'm not selling it back into the grid, I have 5 supermarkets. Yesterday, they were consuming all this electricity. Today, right now that I have my solar panels up there, now all of a sudden, that demand isn't there anymore.
Sure.
Doesn't that change how you think about operating the system or how you plan for the system? I mean, what if everyone did that?
Yeah, so eventually you do start to get into the projected what the load forecast is going to be. And you start to not only in more your more real-time operations, but then further out, how much of this type of generation, more local or distributed generation, are you going to get? Where is it going to be? What's going to be the impact on the load forecast in the future? And that is one of the key assumptions that goes into planning the grid of tomorrow is what that load forecast is. So that's certainly something that we would consider in our different scenarios.
Today, do you have a lot of information about what's going on in terms of changes in demand at the distribution system level? Do you guys have a feel for what's happening there? Do you have information?
Yeah, I mean, through our members, our stakeholders are made up of the distribution companies and the transmission companies, so we work with them to get the information to talk about assumptions and data and things like that. So there's a relationship there to get the data, but we don't have any sort of necessarily direct feed into us of, enter in what your...
But these are the same people who we just heard a little while ago don't know when the lights are out, right? So what sort of information are they giving you, really?
Yeah. You're talking more about forecasts and projections, and you hear about different programs that they may be offering or incentives. We work with them on different pilot projects and things like that to get a feel for what the projection is going to be.
So my guess is, all right, that if with smart grid technology, right, where you now have much greater resolution of information going down to the end use customer, that at the very least, the data the utilities will be giving you in the future, right, will be much more accurate and much more precise. Could you envision a world in which that data comes to you directly?
Likely no.
Okay, and why is that?
The PJM will still be operating at the interstate transmission line sort of system. We do not anticipate getting down into talking to each individual electric vehicle or refrigerator or things like that, each individual home. There's just, we operate more at that wholesale level, keeping the big picture view. Our members have the responsibility of interfacing directly with the customer. We will see things we believe in from an aggregated perspective, so that we will not talk to each individual electric vehicle, for example. We'll likely talk to an aggregator who will be aggregating, summing up that information of what the cars are doing, but at a level that makes sense for PJM to be looking at.
Okay. Paul, you're itching to say something here. So.
Yeah, well, I'm going to, I guess, either supplement or maybe differ a little bit because I'm working with PJM right now on a project where we're exploring the possibility that PJM interval prices could be broadcast through some near ubiquitous medium, sideband of FM or HTTV channels. And involved in that dialogue are also home appliance manufacturers and consumer electronics manufacturers and controls vendors that want to begin putting smart chips in their devices, which if we can do that and perhaps get Energy Star recognition for them doing that, we could very quickly reduce the cost because we would be creating a mass market and potentially have smart devices with an incremental cost of maybe $1 a device or less that actually could begin to benefit the grid even before we get to a point of having a dynamic retail price. They could still be responding to the conditions on the grid and making the grid more reliable and more efficient. So actually some of your colleagues are involved in discussions that actually, not necessarily with two-way communication, but with enabling one-way communication that smart devices could begin to see and respond to.
And Paul, when you say, and I'll get Vladimir in on this, when you say benefit the grid, make it more reliable, specifically, what are we talking? Are we talking about providing ancillary services back to PJM, or what?
Well, there are a couple of things that we're talking about. First of all, if you look at a lot of the devices that are out there, whether it's what's happening in your home with your air conditioner or with electric heating, what's happening in terms of your water heater, what's happening in terms of your refrigerator, these are all loads that have a degree of thermal inertia with them. There are other loads, such as the charging of an electric vehicle or other devices, maybe even things like completing a clothes drying cycle that could be scheduled, or a dishwasher. And so one of the things that we're looking at is how can we take advantage of the flexibility in these loads such that maybe the load decides, well, I can operate now, but then during a period where demand is ramping up, I want to take off for a couple of hours and not and sort of cycle through that period, not running full bore, and then pick up again later in the day. So can we time the usage of electricity to some degree pre-cooling or preheating, to some degree scheduling, based on when your dishes need to be cleaned or your car needs to be charged, and take advantage of the interval-to-interval differences that are occurring in prices. So that's one level. The second level really is at the ancillary service level. And there are many of these devices for whom a 15-minute or a 30-minute interruption really would mean no difference in the service that the customer would see, but would be potentially very meaningful in terms of its ability to provide either reserves or even regulation service, because you could send very time-specific discrete signals, and those devices potentially could respond very rapidly.
Yeah, I would just maybe characterize it a little differently. I completely agree. You're referring to, in the first scenario, sort of price-responsive demand, which is the PJM calculates with those wholesale, you were talking about the locational marginal prices, so we calculate on a 5-minute interval what those prices are and send those out to the different pricing nodes. We envision that there's still be the utility in there that we're working with sending, so we will calculate what the prices are and then work with the utilities to get those prices then. Though absolutely from a technology perspective, the price can go right to your home management system that can decide based on what the price is, do I want to cool, do I want to run, do I want to wait, or how do I want to behave? So the technology enables that to happen without any sort of interference in there. Same with the regulation market that you're talking about. We have done, it's actually my group that's involved in a lot of the pilots with water heaters and refrigeration and things like that as well. Again, our market rules are currently 500 megawatts to participate as a minimum to participate, kilowatts, sorry, to participate in that regulation market. An individual water heater wouldn't hit that level, even if it goes down to a lower level, but in aggregation, absolutely.
Right, and I guess one of the questions that PJM will eventually face is to what degree is a market necessary in this area in the sense of paying people for response, and to what degree will we get to the point where smart devices simply are able to respond and will know, something about, the remaining response that's available out there and, from devices in the grid as we look forward.
Vladimir, did you want to jump in on this?
Yes, I would like to address that from a little bit different aspect. Basically, I would like to reaffirm what both Chantal and Paul were saying. But since I'm coming from Argonne National Laboratory, which is a scientific research lab, I would like to basically try to put that in the context of how do we actually improve the efficiency of these new technologies and new processes that are happening in the grid, in the power system in general. And one of the ways to do that is through improved modeling and simulation. And I'm not saying that the old models that we have now are not so good. I mean, they have done excellent job so far, and they are still very useful in many aspects and so on. But there are some new things that are happening with the power system, and the power system has been going through a lot of changes in the last 15 years or so. And one of them is the electricity market restructuring. So that's a big driver because, now from vertically integrated utilities, now we have competitive electricity markets where we have, competitive supply of electricity, and we have energy markets, we have capacity markets or capacity auctions, we have financial transmission rights and things like that. We have ancillary services markets for various ancillary services that are necessary for the system operation and so on. On the other side, also at the consumer side, we also have a price responsive demand. In the past, the demand was pretty much passive. So the utility operator would basically do short-term demand projection by basically taking a typical daily load profile of the consumers in the area and then adjust that using the weather forecast. So basically, the weather forecasting was the key for developing a projection for the electricity consumption tomorrow. So that was one of the key factors. Now, with the price responsive demand, we have different things that are changing, and the demand is becoming more flexible. It's basically reacting to the situation in the system like it never did before. So most of the customers will soon be getting those real-time price signals and will basically, modify their load profile or their consumption patterns based on the price signals that they receive. There will be, aggregators that will be doing the demand bidding, so they will assemble a large number of consumers and then do demand bidding for them. So we'll have on one side supply bidding. Generator companies will be, providing their bids for the supply of electricity. On the other hand, we'll have demand bidding where the load aggregators will be bidding their demand blocks. But in addition to that, we'll have also the demand response and demand side management as a general category, where even individual consumers will be changing their profiles and adapting to whatever the situation is in the market. So they will be getting real-time price signals, and then we'll be making some changes, deciding to maybe postpone the dishwashing for late in night or do laundry during the weekend and so on. So they may change the different things in their consumption patterns in order to reduce their electricity cost. So one big issue here and the need that we have identified is we need also to model consumer behavior, because that's going to be a big part of the picture of the electricity system in the future. So far, most of the models were doing quite well with modeling the generation, transmission, even distribution system with the electricity flows there. But so far, we didn't really have any of the models that were able to address how the consumers will react to different situations in the system, how they will react to the prices and so on, and what is going to be the change. So for the demand forecast, for example, I see in 5 to 10 years, the utility operator will be basically looking not only into the weather forecast for tomorrow or the day after tomorrow, but they will also consult some models that will, try to foresee or project how the consumers will be reacting to the projected electricity prices tomorrow, so that they take also that factor into adjustment of their
So you'll be able to anticipate when I'm home depressed, watching TV and eating ice cream, and know to ramp up some additional. Oh,
Exactly.
that's good, Commissioner. This all sounds very. This is a whole new take on wholesale energy markets here.
It is. I think the larger picture, and we had a discussion of it on the panel this morning, is that we have a disconnect between the wholesale market, which is really quite vibrant in most of the country, and the retail market, which is essentially priced at a flat price almost everywhere. There might be seasonal adjustments, there may be some others. There's some pilot projects about dynamic pricing. But consumers have a complete disconnect. It's like you would go to the grocery store as often as you do every month, and then you get a bill at the end of the month, and you didn't know what the price of eggs or milk or bread was during the month, even though it changed. You had no consumer power to affect your consumption, and then at the end of the month you would try to reconstruct it. And that's part of where the tension lies, is that I'm a regulator at the wholesale level. Paul is one at the retail level. He has to deal with the fact that it's a vibrant wholesale marketplace, and with consumers who are not used to having a dynamic rate. And that's very inefficient. Now, I understand why it's happened, but I think the promise of the smart grid, with the new technology that allows interactive communication between the meter and the utility, is that consumers can get empowered, and they can make decisions that make economic sense to them if they're seeing accurate price signals. It will be a shift, just like the shift from a vertically integrated telecom system prior to 1984 to a vibrant one today took time. We had to learn a lot of lessons. There needed to be consumer protection involved. But it enabled this incredible new technology and suite of applications that were unimaginable even 10 years ago. I think the same thing can happen with electricity. If we open it up, we give consumers options, they see accurate price signals, and it's good for society as well. I'll make one final point, which is that If in the middle of the summer, those 200 hours where prices of electricity are the highest by far in the year, and you don't have an incentive to turn your air conditioner to a warmer temperature, you're not going to. And who pays the price? The person in the 400 square foot apartment or the person in the 6,000 square foot house? You've got the poor person subsidizing a rich person when you've got inaccurate price signals going on. We can make incredible progress, but the easy thing is for me to say it, because it's Paul who has to take the heat for implementing it at the retail level.
But I like having my ice cream and TV watching habits subsidized.
Everybody loves subsidies. Yes, that's true. But somebody's got to pay for them.
So I don't know, Commissioner, are we up to the challenge of going to some kind of real-time or dynamic pricing at the retail level, or are we?
Well, I hope so. No, I think it's, we're making some progress, and I think it requires a kind of multi-part strategy to really make this work, so that it will take a few years for us to get there. But we're making progress. So so for example, we approved a few months ago a real-time pricing experiment for residential customers in American Electric Power, and those customers are going to get this really cool thermostat that gives them a simple slider between more savings or more comfort, and depending on where they position that slider will determine the amount of variability in their room temperature, in comparison to their set point. And they'll get periodic reports about how much they've saved based on where they position that slider. So, part of this is going to be giving consumers the tools to enable them to address, the dynamics of prices. Part of it is also going to be giving consumers information. Some of our utilities do today paper bill comparisons that show how much you're using compared to how much similar households are using. In the future, you may be able to get real-time comparisons, and with some technology that's right around the corner, you actually might be able to get something that tells you you've got a 1982 refrigerator, and if you replaced it today, you really could save, this much per month, and and here's some coupons for Best Buy. And that's really not very far off. So information is an issue. Understanding how to speak to consumers. I noticed when you did your tribes, there was not a consumer tribe in that utility. And so, understanding that it's not just savings, but it may be empowerment, it may be avoiding the need to build a new generating unit that otherwise wouldn't be needed. It may be comparisons to neighbors. It may be, making and keeping commitments. All of those things may be part of the messaging.
So now let me ask the question of Chantal, then, going back to the operation, because what I'm taking away from this conversation is in fact what goes on at the consumer level, at the distribution level, actually does have some real implications for the wholesale power system. Okay, so I guess the question I have for you is does it really matter from your perspective whether the consumer is adjusting his or her behavior by ratcheting back on their air conditioning or relying more heavily on their solar panel? The difference between generation at the local level on the one hand and energy efficiency on the other hand. Does it affect how you think about operating the system? Does it affect how you think about planning for the system?
Sure. The source matters in terms of the reliability and the stability of the source. So if folks are getting their generation from intermittent resources like solar and wind, for example, that, the sun doesn't shine in the middle of the night and the wind doesn't always blow during the peak load conditions at the beginning of the day, that generation source looks different than if they're getting it from some other supply, if they're getting it from, even, if they're getting it from a battery, for example, there's a certain limited capacity to that. So you want to know, you want to have a feel for what that source is, you have a feel for how stable it is, because if that becomes unavailable, where's the backup power coming from? you know, is it going to be from the grid then that provides the power when the renewable resource is not there? And you still have to plan for that. You still have to make sure that that load is forecasted and accounted for. And you want to know what the stability of the generation source is going to be.
So it would seem to me the more information you had about the characteristics of that load, and even to some extent the historical pattern of demand response or efficiency,
Sure.
right?
Sure.
The more real information you have, I imagine the more precise your calculations can be, and therefore the more sophisticated your planning can be. I guess maybe it gets a little bit to
The modeling,
To the modeling
that you were
piece.
talking about, absolutely, and the more experience you have, because even demand response and energy efficiency obviously looks different than intermittent resources. I mean, we're starting to learn that you can count on DR and EE differently after it's been a couple of days. If you've had a couple of days of real hot weather, then you start to get less of a response in energy efficiency because the comfort factor really kicks in. And those are just human behavior issues that you have to start to understand, and you want to start to be able to model so that okay, I can give it sort of this capacity rating at this period of time, but if it's been a sustained period of heat, for example, I may not be able to rely as much on my energy efficiency as I would before. So, and Phil was talking about the wholesale market versus the retail market. When you were just worried about what the load was and predicting the weather, and those were your two main factors, the economy, being a key driver into the load, it was sort of easier. And now you're starting to recognize that at that retail level, there are a lot of different factors that you didn't really need to worry about before, that onesies and twosies you still may not have to worry about as much, but when it really starts to become a groundswell and you start to get a lot more of the distributed generation and a lot more electric vehicles and a lot more people, a lot more incentives and people participating in demand response and energy efficiency, the larger those numbers grow, the more impact it has. And at the wholesale level, what information do you need? What data do you need? What information? What do you do with that? How do you forecast it? How do you model it? Is all new and something that we need to learn.
Yes, just to follow up to what Chantal was saying, I mean, see, we covered pretty much one aspect of why we need better modeling and simulation. That was half of the markets with the power systems, and that is that we have now a lot of new technologies that we didn't have before. And let me just start with the smart grid. I mean, smart grid is simply, basically, not that we are going to scrap the old grid and put some new smart one in place, but it's basically just upgrading the old grid with some information and communication infrastructure, so that we can operate it in a much more efficient and better way. So smart grid includes a number of different things that we didn't have before, like now we have phasor measurement units like synchrophasors. Then we have advanced metering infrastructure with smart meters. Then we have net metering with the two-way power flows in the distribution systems. We have a lot of smart appliances that are coming up, and every new appliance that you buy now basically is in a way a smart appliance, because you have some kind of information technology built into that one. Then we already have a number of those home energy management systems for residential homes and also building energy management systems for commercial buildings, and they also provide much better efficiency of utilization of electricity in the building sector. Then there is development with regard to the microgrids, where some customers would like to have their distributed generation capable of operating both with the grid and also in an islanding operation. Then The next to smart grid is also wind and solar technologies. We have new generation sources, wind and solar, that are now really a significant source of electricity generation in the system. It's not negligible anymore. So it's a significant source, and they are very welcome in the systems because that's renewable, clean generation and so on. But the size of that generation is in some places in the US already presenting a little bit of a challenge how to integrate that generation in the system in the best way. Then new technology is also the electric vehicles, plug-in hybrid and battery electric vehicles. And that's also coming. We also have now several of those electric and plug-in hybrid vehicles in dealers' showrooms. And in a few years, we'll have probably, President Obama said like 1 million of electric vehicles or plug-in hybrid vehicles by 2015. So it is going on. Then there is a number of different and new storage technologies that may help us with all of these issues. And storage technologies are something that will basically enable smart grid to operate in a better way and more effectively. Because if you just look into the consumer, for example, that's the simplest example. If you are reacting to the high prices during the afternoon or evening peak, the only thing that you can do now is basically just to shut down some of the appliances that you're not using, turn off some of the lights in the rooms that you're not in, and basically reduce your consumption. If you have some energy storage, like for example for the commercial building sector, they could do some shifting of their load from the day to night, so that they charge the storage during the night and then produce some of that energy back during the day. So they may offset quite a bit more their peak consumption by using the energy that they have stored in the storage device during the night. And the storage device doesn't need to be only a battery. It could be any type of storage. It could be a thermal storage like ice or ice flurry and so on.
So you have all these technological innovations coming on, and I think what we're getting from this discussion, right, is you with smart grid you have information flows, right? They give you tremendous amounts of information, and what I hear you saying is you need that information in order to be able to manage all of this new variation on the customer side of the equation. And also having this information makes the system more efficient, right? You can optimize. I guess what I'm also hearing is you need to have, for all the focus that we've put on the meters and the customer information systems, you also need to have at the grid operator level new, more sophisticated ways of using this information, because the equation that they have to solve for on a moment-to-moment basis, which is their operation function, or on a year-to-year or 10-year to 10-year function, okay, requires them to be more sophisticated in how they analyze future demand. Now, I want to shift the conversation just a little bit, because Commissioner Centolella said something very interesting before. He said, well, if you're going to go and build a solar array on people's roofs, if you're selling into the wholesale system, then wholesale markets get involved. But if you're just consuming the power locally, then it's not really a wholesale issue. But I guess what I'm hearing is no matter what you do, you're having an impact on the wholesale market. So that gets me thinking. Should we just turn this all over to Commissioner Moeller? Isn't this just one big wholesale market? I mean, why do we need you, Paul?
Well, I do think that the role of regulators is changing, and that there is a need for regulators to understand, the wholesale markets, and to work with them, and for us to have a partnership in how this goes forward. And in some areas, there will be eventually a need for, for state regulators to get out of the way and, and let markets function. I mean, Phil mentioned the cross subsidies that are inherent in our flat prices and the grocery store analogy, which is a great one. I mean, this is the way we've done things for 150 years because that was the only way we knew how to measure it. And now we're at a time where the technology enables us to do other things. And so one of the things that that we're very much looking at is how do we better enable new competitive retail innovation to come into our local markets. So so for example, I had a competitive retail supplier in my office a couple of weeks ago who told me about all the the neat offerings they were going to be able to do for customers, packaging, efficiency with energy and a lot of other things. And I said, and oh, by the way, we have this application that fits on your smartphone. And when your phone drives away from the house, it powers down your house. And when you drive back into the neighborhood, it'll power it back up. This is an application that I talked to Microsoft and Google about and mentioned in conferences 2 years ago. And here's somebody in my office who's actually doing it. And this is, the power of having retail competition come into markets in ways that enable a kind of richness of retail competition and not just, well, I'm going to provide you, 5% off of
They may want to pay more for just wind power. And so I think we're on the verge of that. And even though it's a little early for closing comments, what I look at is, I just think it's a fabulously exciting time to be doing these issues, being in this industry, and I hope that optimism is shared, because we're at the verge of some really exciting decisions where we're going to go, and we can clearly improve the efficiency of the system. It will depend, I believe, largely on proper price signals being sent to consumers. But if we send the right signals, we can do things so much better. If we send the wrong signals, we can be spending a lot of money we don't need to spend to meet peak consumption periods.
Well, and I also think, and I'll toot the horn of the commission for a second. I also think that that FERC has really done some really visionary work, not only in some of the wholesale market orders that have come down over the number of years and months, but even in this most recent one, which has the planning authorities now looking at non-wireless alternatives as part and parcel of their planning process, right? So that transmission, energy storage, the variety of strategies that consumers can engage in, demand response, efficiency, the photovoltaics on their roof, that all of those things now come into the decision-making process, because as we all know, utility infrastructure is very long-lived. And so that transmission wire that you build today can have a profound effect on the market dynamics, inadvertently crowding out other opportunities, right? So that becomes a really important, I think, piece of the puzzle, and you and your colleagues at FERC have done really a tremendous job in recognizing that, I think.
Well, we'll see when the compliance programs come in, but that's a year away. In a few minutes left, I'd welcome folks to get in on this conversation. If you have a particular question or an issue that we haven't covered, or something was unclear to you, please let's get that on the table, sir. And if you would just identify yourself when you ask. Okay, Don. Well, I don't know. Chantal,
Wouldn't it be so wonderful to know what the prices are going to be? Yeah, I mean, we get that question a lot, is you need to be able to build a business case and understand, you can understand what the costs are likely going to be going out, but what are going to be the profits or the revenues that come in. You can't predict what the prices are going to be. Lots of things come up. For example, if you think of the regulation market there, for a while it was operating at about $40 a megawatt hour, and then this Marcellus shale thing came around, and it's really looking that is going to be the marginal fuel, and prices right now are around 20. What else is going to pop up? Energy storage is coming into the regulation market, very inexpensive. Is it retail or is it wholesale?
Well, I would think that the cogen would probably be selling into the wholesale market. Now, I will say that I think this is one of the places where our wholesale markets are broken to some degree, because we today set resource adequacy requirements on an administrative basis through administrative type markets. And as a result, for a lot of reasons, we have then not seen very liquid forward private markets develop in this area of the kind that would be necessary to be able to finance your cogen operation. And this is an area of of continuing concern about how do we fix that so that we're not dependent on what's basically an administrative mechanism and the uncertainties associated with that.
I think those kind of projects, I've been familiar with a few of them, they solve several problems, whether it could be potential groundwater contamination or getting rid of, say, manure, but those solutions aren't really priced. They're good for society, but there's not a way to incorporate them into the price of the electricity that is generated from that. So that is part of the challenge, is one of these multiple benefit facilities, getting the revenue stream that reflects the benefits that they provide.
Well, and as Commissioner Moeller knows, because we've had this conversation many times, when you talk about getting the environmental attributes of various forms of generation priced into the price of electricity, okay, one of the reasons why our energy policy work at Environmental Defense Fund is complemented by our work to make sure that there are strong pollution standards in place, that there are caps on key pollutants, and that those caps are declining over time, is because there is a necessary complement that you need to have between what you're doing to get wholesale and retail energy markets to operate efficiently on the one hand, and then on the other hand to make sure that the environmental attributes are properly priced so that it's reflected in the price signals that are in the marketplace. That pricing comes from things like putting caps on carbon. Whether you do that at the regional level, like has been done in California or the Northeast, and has been tried here in the Midwest, or the price on NOx emissions. There's a cap here in the Midwest, okay? Those are the ways in which you begin to get the environmental attributes into the energy markets. Sir, back there.
Well, I'll jump in. There was actually a 2007 federal bill that directed us at FERC to develop interoperability standards for the smart grid. Now, we're not a telecom or a scientific agency, so it was kind of an odd spot for us to be given the directive from Congress to do this. But nevertheless, we went about it. We were tasked with deciding whether to adopt these standards, the standards of devices talking to each other and talking to the grid, the protocols. Once the National Institute of Standards had developed them and had reached sufficient consensus, that was the phrase from the bill. So we started up a dialogue with our colleagues from the state commissions. Paul was a real leader and continues to be on that. And worked through this standard development process that had hundreds, if not thousands, of people involved. And we finally decided in July of this year that sufficient consensus had not been reached, and we could not follow the mandate of the law. And so there are a number of processes that are still going in the standards development process, and from what I've heard, it's going pretty well. But you point to a larger issue, which is that we were essentially tasked with setting standards that affect the retail level, blurring the jurisdictional line in an uncomfortable way. But one of the reasons Paul and I talk a lot is to try and keep the open communication channels. But you can see where that's going. You can see that there's a convergence of a jurisdictional blur over who controls what. So eventually we may need that. In the meantime, I think we can make it work, but I'll hear what Paul has to say.
I do think we can make it work, and there is this really interesting public-private partnership that has evolved called the Smart Grid Interoperability Panel, which now has more than 700 member organizations, both in the U.S. and around the world, that is trying to develop interoperability standards for precisely how the smart grid will develop, such that U.S. manufacturers of equipment, for example, will be able to sell in Japan and Korea and China and the EU. And we will be able to get to a point where equipment can talk to one another. And that's a very important effort in terms of making this all go forward. And there's been really quite remarkable progress. But I do want to go to this question of, where could federal policy really make a difference? And I think one of the areas where it could make a significant difference is in continued and expanded support for research and development activities. For those of you who are not familiar with it, get familiar with a program in the Department of Energy called the ARPA-E program, the Advanced Research Projects Agency for Energy. And for example, they just awarded a series of awards under what they call their Green Energy Network Integration, or GENI program, that will, if these high-risk, high-reward projects now enable us to actually begin to direct on an equal way the way power flows through the transmission system, be, model in a way what is going on in the power system. Also doing great storage, they're doing great capture work on and think that along with things like the DOE innovation really changes in a very dramatic and all should be.
Well, that's a good question. I think it's something perhaps we have to revisit. The affiliate rules are there so that it's fair that an affiliate does not have information that would advantage it in the marketplace. But I'm glad you brought it up. I don't think we're there yet. Perhaps we'll get to a point where that needs to be revisited, as long as consumers are still protected.
Well, and every session should end on an affiliate rule question. Such a crescendo. Thank you all for your very good questions, and thank you all for your attendance and your participation in this, and please join me in thanking the panelists, who I think did a wonderful job. My understanding is I'm looking at Josh back there. Lunch, Josh? Lunch? Okay, so lunch now. Grab your lunch.